Welcome everyone. This is the second part of the chapter motion for class 9. Okay. Today we'll discuss two very important points, and the points are distance and displacement. Okay, distance and displacement. Today we will learn only about these 2 points. So first let us discuss what is distance. What is distance? Suppose this is a point A. This is a point A and a person is standing here. This is a curved road that the person takes to reach another point B. Listen carefully what is happening. The person is traveling through this path slowly and he is at point B after some time. Now, if I ask you what is the total path actually covered by the person, okay, total path actually covered by the person, how will you find out? Think of this. How will you find out? To calculate this distance, obviously we need some measuring tape or some measuring device. Here I have a small piece of measuring device. All of you know what this is. This is a small rope. Okay. Now let us see how we can measure this actual path covered from this point to this particular point B. Let us see how we can find out. For this, what we have to do, we have to place this measuring device at the starting point A like this. Then cover this path with the device this way. Then we cover this path again like this. Then we cover this part. Then we cover slowly this part like this. Then we go on covering further and further and finally up to this point B. Okay. So I started from this starting point. I hope all of you can see this, and ended up here at this point, this part. So from the starting point here to the ending point here, this is the total distance that the body has covered. From starting point here, this is the starting point, this one, and it ended here. So this is the total distance that is covered. Okay, this is the total distance that is covered. So the path that is covered, the total path that is covered is known as distance. The total path that is covered is known as distance. So you note this definition. The total path that is covered is known as distance. Now let us check what is displacement. Now for displacement again, what we will do, we will take the same measuring device, but here instead of going along the path like this, what we will do, we will place the measuring device or measuring tape at the starting point like this and straight shortest path directly to the last point. Okay, we will start from the starting point here and place it directly to the last point. Can you see the difference? While calculation of distance, what we did, we went along the path like this, okay? But in case of displacement, what we do, take the starting and the final point like this. So basically this is the shortest distance between the initial and the final points, okay? So this distance, the shortest distance between initial and final point. The shortest distance between initial and final point is known as displacement. Shortest distance between initial and final point is known as displacement. Shortest distance between initial and final point is known as displacement. Take a note of this. Okay. Now think about this. Whether distance will be greater or displacement will be greater. Think about this. Distance will be greater or displacement will be greater. Distance is always equal or always greater or equal to displacement. Displacement is always greater. Sorry, distance is always greater or equals. In the minimum case, it will be equal to displacement. Okay. In minimum case, it will be equal to displacement. Now think about a particle which is moving in a straight line like this. An object going from A to B. From A to point B. In this case, the path is along AB, straight line path. So, if I ask you to measure distance, you have to go along the path, so the rope will be straight like this. If I ask you to measure displacement also, again you have to go from the shortest path, straight from A to B. Again it is the same measurement you will get. So in this straight line motion, what happens? Distance and displacement becomes equal. So in this measurement, distance and displacement becomes equal. So it's a special case only. But in most of the cases, distance is greater than displacement. Okay. So displacement can never be can never be greater than distance. This point you remember. Displacement can never be greater than distance. Done? Again, distance covered by object. Distance covered by an object by an object can only be by a moving object, can only be positive. Displacement can be positive, negative, as well as 0. This point you remember. Distance of a moving object. If an object is moving, that is changing its position with time, then its distance should always be positive. That means always its distance will be increasing with time if it is moving. But displacement of an object can be positive, it can be negative also, as well as it can be 0. Okay, displacement of an object can be positive, negative, as well as 0. Third point we can discuss this. Distance has no specified, no direction. It is a scalar quantity. It is scalar quantity. It is a, I'll write it here. Distance is scalar. Displacement is a vector quantity. So these are some differences between distance and displacement. Now what is a scalar quantity? Okay, in physics, a quantity that can be measured is known as a physical quantity. Okay, and there are some quantities which can be specified. That means that can be understood only by taking their magnitude. Okay, their direction is not important. Suppose distance. The example that we gave like this, from A to B. While measuring this particular distance, whether you go from A to B or you come from B to A, this direction is not important here. Okay, you will get the same magnitude. Magnitude of a quantity means magnitude. Suppose I say that a body has a mass of 50 kg. Suppose I am saying that a body has a mass of 50 kg. Okay, this is the magnitude of that physical quantity. 50 is the numeral and this is the unit. This is known as magnitude. Okay? Now what is a vector quantity? Vector quantity is something. What is a vector quantity? Vector quantity is something which needs both magnitude and direction, and follow some special rules for addition. Vectors are, they have magnitude, they have direction, and follow special rules of addition. Such quantities are known as vector quantities. Some examples of scalar quantities are mass, time. These are physical quantities which are classified as scalars. Mass, time, speed, etc. But some vector quantities are force, then we have velocity. You will understand these quantities slowly. Okay, these are the quantities which needs magnitude as well as direction for their complete specification. Okay, I hope you have understood some of the points. So what is important here? Distance and displacement. Difference between distance and displacement. And you have to understand that there are some physical quantities which needs only their magnitude for their complete understanding. Suppose if I ask you, what is your mass? Then your answer may be 45 kg, 50 kg. That's enough. I will understand that your mass is 50 times of 1 kg, 45 times of 1 kg. That is enough. But if I ask you what is your weight, okay, if I ask you what is your weight, then you may say 45 kg weight. That's the unit of gravitational unit of force of earth on our body. Suppose 45 kg weight. That means you have been pulled downwards towards the center of the earth with some force. Okay, so here it has direction. It has some magnitude. What is the force? 45 kg weight. And in which direction you have been pulled? Towards the center of the earth. So there are some physical quantities which have both magnitude, which have that means both magnitude and direction. Such quantities are known as vectors, provided they follow some special rules of addition. Some examples of vectors are force, velocity, etc. There are a lot of examples. And for scalars, we have these physical quantities, mass, time, etc., which do not have any direction. Their magnitude is enough. In the next class, we will discuss about speed, velocity, average speed, average velocity, and do some numericals. Thank you.